Welcome to AHDB Agronomy Week 2020. The live stream session will start shortly. Before we begin, we wanted to remind you of a few points of housekeeping. You're all on mute, so don't worry, we can't hear you. The session is scheduled to last between 1 and 1.5 hours, including questions. We want this session to be as interactive as possible, so please post your questions throughout the session using the live Q&A function in the Agronomy Week platform below. We're recording this session, so if you miss anything or would like to watch it again, it will be available on the AHDB YouTube channel and AHDB website. You can also come back and watch the recordings on the Agronomy Week platform for 3 months. At the end of the session, we'll provide you with unique BASIS and NROSO codes. Don't forget to complete the BASIS and NROSO forms using the relevant tabs on the platform. You have 2 weeks after the live session to register for your points. Join in the conversation online. Follow AHDB_cereals and AHDB_potatoes on Twitter. Use the hashtag Agronomy Week. If you have any issues with the conference platform, there are digital event FAQs in the menu on the left-hand side. You can use the Help tab to contact the team if you experience any technical problems during the week. We hope that you enjoy Agronomy Week 2020. Thanks for joining us. Your session will now start.
Good afternoon to everyone and welcome to the second to last session of Agronomy Week. So some of you might know, but for those who don't and thinking, who's this guy with the dodgy beard? I'm Alex Ways. I'm the Knowledge Exchange Manager for AHDB Potatoes, covering the West Midlands, South West and Wales, and I'll be chairing the session today. So this afternoon our session is going to be on overwinter cover crops ahead of potatoes. Now, in potato farming, potatoes can be damaging to the soil structure and tend to be a little bit harsh on the soil, and cover crops can help regenerate them, as well as harbouring, many other benefits, such as protect the soil from erosion, provide fresh organic matter that will improve the soil tilth, prevent the leaching of nutrients. Some serves as sources of nitrogen, specifically in the case of legumes, and they also help in the management of certain pests like weeds and nematodes and many more, which our speaker will touch on. So our speaker today is Mark Stalham from Mark Stalham Potato Consultancy. However, as I'm sure a lot of you are aware, Mark is an old employee of NIAB, and today he will present on behalf of Mark Allison from NIAB on a joint cover crop research they did. Most of the work reported on is from the Rotations Partnership, which was a big project funded by both AHDB and external sources, and there is a great deal of valuable detail in the project, which most people, including myself, won't have had the time to read the final report. So, this is our chance to hear about the important bits, explained in context by Mark, who's someone who doesn't just do research, but he reads other people's research and regularly and actively talks to growers and agronomists. And most attendees probably will have already seen the chart of effects on yields of numerous cover crops pre-potatoes, and on average, I think it's fair to say they increase yield, but there is a wide range. So I think today Mark will also explain under what circumstances cover crops increase yield, and also, almost more importantly, when they don't increase yield, and also touch on what can an agronomist do to ensure they always result in yield increase and protect the soil against damage. So the session is targeted to finish at 3 o'clock, depending on the volume of questions coming in, with a few polls throughout, and as usual the Q&A at the end, but make sure to get your questions in throughout the presentation. So without further ado, I will hand over to Mark to kick off today's session.
Well, thank you, Alex. I thought you were going to carry on and deliver my entire talk for me. So yes, you've alluded to some of the areas we'll be talking about, but very simply, I'm presenting here as a sort of co-partnership with Mark Allison. Mark Allison leads the project, and when I left NIAB 3 weeks ago, I was working, very much on the project. So this is a combined project, but to be aware, this is about the sort of physical conditions and the effects of organic amendments and cover crops on those properties. It doesn't really delve that deeply into the biological or the chemical properties. Certain areas of soil health are covered by one of my ex-colleagues, Liz Stockdale, in the soil health program, which runs almost concurrently with the project. It's got another year to go. We've only got another 6 months to go. And so what I was asked to do by Anne Stone is to deep dive into a couple of crops, rather than, as Alex has said, just show the overall summary without really any understanding about how this yield benefit has occurred. So what we're going to do is start you off with some interactive stuff. So if I can have the next slide, please. So a poll. Basically, Alex has mentioned several things, but I've put 4 things up here that I regard as being very important for growing a cover crop. So you can see what we might be looking there in terms of biomass, pest or pathogen control that Alex mentioned. Particularly improving cultivation and soil structure is one of the areas that I'm very much focused on with collaborators at JHI, Blair McKenzie, and also with Andy Binley and Katharina Huntenberg at Lancaster. So how do we improve structure with using cover crops and amendments? And the other one is if you're on sloping ground or soil that has very little retention capability of nutrients and water, can we improve the capture of those particular elements? So if we move on to the next slide, please. So very simply, there are the benefits of cover crops. I've put 5 down there, and we're going to touch on a number of those. Possibly biofumigation, we won't touch at all, but possibly we won't go into soil mining to overcome compaction. But we welcome your questions on it. Go outside where I'm going in the talk, ask the questions, and we can carry on that conversation at the end. So next slide, please. So the answer from the poll. Now, I did a similar talk on Wednesday, and I was conscious that as I carried on talking, the polls being A and B actually sometimes almost reverse the other way. So we can see they're going up and down a bit, but basically I'll leave it going. It's quite interesting seeing the bars going up and down, but the 2 leaders clearly are for control of pest or pathogen. We really won't be touching on much of that in this talk, except when a little bit we talk about the oak cover crop. But improving cultivation and soil structure is where I'm going on that. So very interesting. We've picked the right subjects for people to discuss. Okay, let's go to the next slide. So Anne Stone asked me to deep dive into a few specific crops, and we're really going to pick about 4 crops to have a look at and try and untease some of the effects. Okay, next slide, please. So the first one is a series of 3 trials that we've been running in 3 years of the program at CUF. Basically, we've had a cover crop drilled since autumn 17. So when I talk about 18, 19, 20 seasons, that means the potato crop in the following spring after the cover crop was sown, typically, as you'll see there, in mid-September, drilled at reasonably low seed rates of about 70 kilos, not a commercial seed rate up into the maybe 100, but enough to give us a ground cover. With the exception of one site, particularly in 2020, we really didn't have many weeds in the cover crop. It was just the variety and the species we wanted when we drilled, and no fertilizer was applied to the cover crops, albeit we may have adjusted the P&K prior to the potato crop, but that would have been very close to when the cover crop would have been desiccated or removed with cultivation. Okay, next slide, please. So very simply, let's begin with the first year. March and April, you can see the dates there. Early March, we had a very sparse ground cover by that date, and by the 16th of April, another month further on, it certainly had grown, but it was a very cold winter. We got poor establishment. However, when we look at the box of soil on the bottom left, the sample you can see that's very crumbly, has got moderate clod sizes, comes from an area that had cover crop that was left right through until primary cultivation, in which case this was plough, and that was done pretty much around that time of the 16th, 17th of April, 2019. So, I'm sorry, 2018. Whereas the big block of blocky compacted soil was dug out of an area that was just existing in the previous cereal stubble, and all it had was the tines passing over from the area of where they were drilled. So it's had minimal cultivation since the preceding cereal crop. So effectively, you can see that poorly drained, massive soil. That's a very big contrast. I couldn't get the sample that had been ploughed from a neighbouring half of the field because it just literally would have flowed out of that tray. It was just literally beyond saturation. So that shows you the benefit of having something growing, in this case oats, over winter compared to having nothing. Okay, next slide. Right, so contrast this with a year further on, and you can look at the crop there. You'll see some data in relation to dry matter production and nitrogen uptake in this crop, and you'll see it's very large. But what we're doing there in the background on a Saturday morning is actually mowing the crop to allow us to break it down so we didn't have long stems that we had to bury when we ploughed it. So you can see the sort of different stages of crop growth that we get into contrasting seasons with the same drilling rate, no fertilizer, and the same drilling date effectively. Okay, next slide, please. So if we move on another year, and you can see this perhaps not quite as easy to see, but actually 2020 was another lush green crop. We've got a few more weeds in there, which isn't being shown in here, but you'll see the data in terms of the uptake of nitrogen a little bit later on. Okay. So what we've got here is the 3 fields, the 3 years of the experiment, and typically sampled in either late March or early mid-April. You can see the dry matter yield on that first sparse crop was only 2 tons of dry matter, whereas we got nearly 4 times that in the second year where we had to actually mow the crop before we ploughed it. Not irrespectively, you can see there the nitrogen content. It doesn't reflect the overall dry matter content of the crop, but it certainly reflects that we've got nearly twice as, or more than twice as much nitrogen uptake in 2019 as we had in the 2 contrasting years. But you can see the nitrogen content does fluctuate in relation to the dry matter that we've got there. Now, interesting there, you've got the carbon nitrogen ratio that very much higher in a more lignified, stemmy crop in 2019 compared to the very leafy material and sparse that we got in 2018 and 2020. And that will be important in terms of the breakdown. The lower the CN ratio, the more active we can break it down, the quicker it will break down. So 2019 may have been slower to actually break down than the other 2 crops. Okay, next slide, please. So what we're going to do now is some of the soil physical effects. And what we've got here is a combination of measurements of soil water content measured at basically on the surface. So literally the top 5 centimeters versus down around about the depth that we might consider doing some primary cultivation, whether that's inversion or fixed tine, typically 25 to 30 centimeters deep. Throughout this talk, if you can see any areas highlighted predominantly in red when everything else is either black or blue as text, that is when we've got significant differences statistically. So that's why it's highlighted that way. So what you can see is on the 21st of March, 2019, we actually had a drier surface layer where we had no cover crops growing. So therefore, the wind was evaporating water and it was drying that top 5 centimeters of soil. But at depth, there was no difference in the soil water content. If we move to the 1st of April, pretty much around the time we're thinking of doing our primary cultivations to get our secondary ones done and planted, you can see there that the undesiccated crop has actually dried even further. So we've still got good drying on the surface. And now we've got those other 2 crops where we've had a crop that's been growing the whole winter, or one that's been defoliated 3 to 4 weeks earlier, actually now beginning to dry out from surface evaporation effectively. But what you can see is there's another red number there where the growing crop finally on the 1st of April is beginning to suck water out at 30 centimeters. And that would make a change from soil being at field capacity to slightly lower than that. And hopefully we can avoid damage at that particular point. The right-hand column is the bulk density. And what we're looking for is basically low values. And you can see there that we've got numbers in 2019, typically in the top 10, 12 centimeters of soil, around about 1.16, 1.2, and that's pretty low. Whereas in 2018, we had a much higher bulk density. And you can see there that perhaps the benefit of the crop in 2018 was that soil was much more dense and we're improving soil structure just by allowing some porosity to occur. So difference in seasons, we're already seeing differences in soil properties here between two contrasting seasons. Okay, next slide, please. So move to this year, and you've got some pictorial images there of a crop that was sprayed off early. We didn't have a crop that we basically didn't plant with a cover crop in 2019 leading into 2020, but we had different dates of spraying off versus something that was left right and through until the primary cultivation. You'll see pictures of that in a moment. So the soil water content largely similar on the surface, but on the 21st of April, when we were allowing the soil to dry out, now notice that's the 21st of April, not the 1st of April, we had to allow the soil quite a long time before it starts to move water at 30 centimeters. So it was cold, it wasn't that dry, it may have been bright, but we had to wait for that soil to inexorably dry out. The consequences are, the pictures you can see on the right-hand side are the spade picture with the broken down soil is the undefoliated crop, which was friable at depth. And you can see that nice little 4 millimeter to 5 millimeter thick string, which was where the crop was sprayed off early back at basically the 21st of February. So the soil didn't dry out, it was still plastic, and therefore we would get compaction damage in likelihood from that crop that was sprayed off early, whereas the undefoliated crop was moving in the right direction of drying out and becoming suitable for cultivation. But we did have to wait a long time for this to happen. Next slide, please. So that's the picture we've got. What we're mimicking is trying to get the picture on the left, which is the broken down soil, and we achieved it in 2020 at depth. And what we had where we didn't do any drying out is more like the block of soil that we have on the right of that picture. Okay, next slide, please. So what we started in 2019 and then followed up on 2020 was a visual evaluation of soil structure. Next slide. This comes from work that Bruce Ball did, and you're breaking down into 5 different categories, and you can see basically the cloddy, blocky, massive structures that are basically high values there, a 5. The top of the picture, you've got a 1, which is very loose, friable soil, the sort of thing you'd have in a cereal seed bed if you got it right. So we're looking for a potato seed bed, probably a good 2, hopefully not too much 1 before we do any secondary cultivation, because it will break down too much if we have too much of that top image there. So follow through to the next slide, please. So what we've got there is 2019, and we can see following through the winter. And the clear thing there is it's only when we get close to the time of primary cultivation at the end of March that we start to see a change in friability. Interestingly there, the no cover crop, which was the one that was evaporating water from bare soil, did improve from the 20th of March to the 29th of March, but otherwise there was no improvement there. So despite all that process of trying to dry the soil out, on the surface, we were not seeing that benefit in terms of soil structure. Okay, next slide, please. So we go through to 2020 and we look at basically what happened just prior to that primary cultivation going on the 21st of April. We've got there undefoliated, which is actually similar to defoliated late. They're better than the previous year, they're much more friable and crumbly, but the defoliated early, which is the crop that had a mulch of desiccated tissue, which you'll see pictures of in a moment, was actually significantly higher in terms of VES. In other words, it was a worse structure on the surface. So that's an interesting contrast with 2019. So bear that in mind when we come to talk about the yield and the other benefits a bit later on. Okay, next slide, please. So we've got a former yield, and that goes through ground cover. So in 2018, there's not many people out there that could say any of those ground cover curves are any different for any of those 3 treatments. Maybe the no cover crop slightly earlier senescence, but effectively there's no significant difference there. 2019. Next slide. Thank you. 2019, no effects whatsoever on ground cover. Okay, interesting. Next slide, please. 2020, this is emergence data. And what we can see there is that basically we've gained a week in emergence from a crop that was actually defoliated on the 21st of February. And we weren't cultivating this field until the 21st of April. So somehow we've got a benefit in emergence, which is about a week. Did that actually reflect in anything else that happened in the season? So next slide, please. Right, next slide is the red line is the early defoliation in this case, and we gained a week in getting to full ground cover. and it didn't senesce any earlier. So in likelihood, unlike the 2 previous seasons, we should generate a yield difference in early defoliation versus either the crop growing until cultivation, or the one that was desiccated much closer to the point of primary cultivation. Next slide, please. So we're going to go through the 3 years of yields. Basically, you've got here the 2 red numbers there are significantly differences between cover crop growing for the whole of the season, undefoliated, or one that wasn't actually, or was planted and then burnt out immediately. We can see there's a lower yield in the crop that was actually defoliated. So why would that be? Let's go on. We'll try to explain some of these differences. 2019, please. Next slide, please. Right, so can we go back one slide, please? Thank you. 2019, we can see there all the numbers are blue, therefore they're not significantly different, but there was a numerical advantage in actually not defoliating the crop. So that's in contrast with the previous season. Right. Next slide, please. And so we get the complete contrast to that. The crop that was defoliated early was actually numerically and significantly different, higher in 2020. So we've got 3 almost contrasting results in terms of the yield. How do we explain this? We're going to go through that in a moment. So next slide, please. So in summary of this oak crop at Cambridge, where we had no cover crop growing for 2 years out of the 3-year comparison, and comparing that to where we didn't do anything to the cover crop until we ploughed it or cultivated it, right at the point of planting, we had a difference of about 1.9 tonnes per hectare. And bear that in mind when we come to talk about the average results of cover crops, and we'll return to that. If you look at the one where we defoliated the crop early, comparing with leaving it right through to ploughing, we actually had no significant difference. So out of all the things we've got to do in terms of managing this crop, either mowing it or chopping it or doing it, is it worth the hassle to actually have to do this right close to planting? Or is it better just to burn the crop off well ahead of planting, and actually then you're in a position whereby you know your soil is fairly stable in terms of rainfall? However, this is a difficult question to answer, and I don't think we've fully answered it, even with 3 years of experiments on a very similar crop at Cambridge. Okay, next slide, please. So this is just a quick question to break you up. Basically, what's in people's minds is the typical interval for defoliating a cover crop prior to planting the crop? Is it very simply less than 3 weeks, or is it greater than 3 weeks? It's not going to give you the exact number, but it's either more or less than 3 weeks. So we'll wait for that poll to go and come back. I'm going to go to the next slide, please. So here's an example of it whereby we've got early and late desiccation. The crop that was sprayed on the 18th of March, there you can see is dead. There's no green material. It's actually fully dead, and it's almost straw-like in terms of its carbon-nitrogen ratio. What you've got on the 23rd of April is basically the point when we were just about to invert this field or cultivate it, which you'll see in a moment. And you can see it's dying, but it's not dead. So we've basically used glyphosate to kill it, but it hasn't completely killed it in the time interval that we've had, which is 8 days at that point. Okay, next slide. So the results of the poll are most people do it more than 3 weeks. So sort of coming back to the last question, which I won't tell you what it is at the moment, right at the end, will be, is it worth the management hassle in doing this? So next slide, please. So I'm going to stop now because this is a video that we've embedded, and so it's going to have to play without my voice. Right, thank you. So I'll summarize that in that you can see this year in 2020, we did not invert the soil. We ploughed in the 2 previous years, but this year it was deemed that our soil was too heavy on one part of the field to invert at this stage in April. So we used this new cultivator with a 2-pass progressive depth, and it produced a very good job in terms of cultivation. So if we go through to the next slide, please. So you can see there, one of the issues we've got where we didn't actually desiccate the crop well ahead of doing this cultivation is the bottom picture shows where we've done it. The top picture shows the sort of mess that we've actually got where we're trying to bury sort of 25, maybe 30 centimeters of green leafy material below the soil. Now, we don't destone, we rotary cultivate and produce ridges directly onto that. So this wasn't a big an issue, but we have had very few volunteer issues from crops that have been unsprayed. Yes, some, but not enough to really be detrimental to the crop. So we can get away with it, but if you were destoning, there's clearly an issue there, which we would try to address by disking the field or mowing and chopping to basically produce leaf material in a long length. So those are the two contrasts with what we've got in terms of desiccating the crop at different stages. Okay, next slide, please. So that's, in summary, Cambridge. This work really stemmed from work we did with James Dorr at the Spot Farm West in 2016, when I was called basically across at ploughing time by James himself to say, you've got to come and look at the consequences of what we've done in terms of planting a cover crop versus not planting a cover crop. And the little image you've got there on the 8th of March, that was very kindly sampled by Mark Taplin of Harvest Agronomy, who basically took samples. We compared the nitrogen uptake, and we also compared the water content under an area that was actually growing with cover crop versus one that had been basically cultivated in autumn without any cover crop. And whilst there's a sort of a consistent difference between the crop that was basically left to grow, that's the top three lines, between 10, 20 and 30 centimeters in soil water content, compared to a crop that was actually desiccated very much closer to planting, it was only 1%. That's not a big difference, but the difference in soil structure you'll see in a moment, and Mark Taplin indeed himself did say when he returned to dig samples up for me that the soil structure was completely different. And we found that right the way through until we came to dig up the samples in September later that year. So is it important? It's clearly the right direction in terms of drier under an undesiccated crop, but how much difference is that really imparting to the crop? Next slide, please. So I went up on a Saturday morning and James called me over to the field. And basically what we saw there was the consequences of the image on the right-hand side, which is where the crop was undefoliated at ploughing. You can see how the soil is broken down. Very easy. Now, you know, it could be there was a change in soil structure, but that doesn't reflect the picture. And the line up the field was exactly where we planted the cover crop up to versus where we'd actually desiccated much earlier in the season. So you can see the change in soil structure. Having the crop growing was markedly different in terms of, you know, having a soil structure that was cultivatable versus one that needed more work doing in terms of operations. So you can see those operations and the four guys that were doing all the work there, you know, the guys doing the ploughing, which is on an earlier date, but then the bed forming took place on the Sunday and Monday. And when I returned on the Monday, I was told by the drivers, if only we'd had the whole of the field done with cover crop that had been undefoliated, we would have left the field on Sunday and not still be here on Monday morning to Monday afternoon. And the reason is because the rates of work were so much faster in all operations, from plough through to bed forming to bed tilling and destoning. So typically anywhere from 12 to 24% faster in terms of overall speed. And that would help in a season where we were getting towards the end of a planting window and rain was beginning to be forecast. So planting windows here, improving the speed is a massive advantage. Next slide, please. So did it bear out? Well, yes, it did. Now, these are basically unreplicated trials of a standard error is just 3 digs done in the same strip of each of the treatments. But numerically, there's a very big advantage in leaving the crop growing for effectively another 3.5 weeks in this example. So you can see there that, you know, another 9 tons per hectare advantage in total yield would be something that we'd be very, very convinced about if it was in a replicated experiment. But here it's in the right direction, and we'll put that through in terms of some of the data we've got from our other crops in the Rotations project in a moment. Okay, next slide, please. So Anstone, you can see there, basically down in Somerset in 2018. So we'd moved on. She took some measurements with the staff down there of fuel consumption, work rate. and basically with and without a cover crop. So you can see her and David Cliff standing in a cover crop in that field. Basically, the cover crop consumed less fuel and had a faster work rate on most operations. Not always was it a big improvement, but nevertheless, the fuel saving on two major operations, primary and bed tilling, was a significant improvement there in terms of reduction in fuel. Okay, next slide, please. So what we're going to talk to you about now is we've talked about a crop that basically goes through from September, drilling in August maybe, through to the point when we're having to make a management decision, maybe late March, early April, where you've got lots of other things going on. There's other fields being cultivated, planting, and sometimes the foot can be taken off the throttle in terms of managing those fields individually. So to get away from that, why don't we just say we'll grow the cover crop perhaps a little bit earlier, maybe an August planting, and then just take it out so that we gain as much benefit as we can pre-winter. And so therefore what we've done here is Mark Tinsley has conducted some trials with Mark Allison on cover crop of oil radish, and you can see the picture there whereby you've got a strip that's been taken out of the field, not drilled, versus either side you've got the stage of crop growth, which would be on the end of September, looking at the crop actually flowering. So much higher CN ratio because it's more lignified, lower nitrogen content, but a very big biomass compared to the crops I've shown you grown at Cambridge in terms of oats. Okay, next slide, please. So what we've got here is the cover crop N uptake, and similar to the oat data at Cambridge, there's variation between years. So in 2017 and 2020, we had about 111 to 130 kilos of N uptake, with an CN ratio of around about 17 to 18. But the crop that grew much more rapidly produced a much higher yield of dry matter, so 12 tons of dry matter in 2019, basically took up 240 kilos of nitrogen during its growth period. So you can see there a very big difference in what we're taking up and higher than the oat crop that we were growing in Cambridge. Okay, next slide, please. So was that borne out in terms of yields? Now, if you look at the numbers there, again, they're replicated digs in strips, so you can't analyze between those two treatments. But you can see there at the bottom, there's a number in red. And this isn't a statistically significant difference, but it's something you probably would expect to be different if it was in a well-replicated experiment. So you can look there, 6 tons per hectare in one of the 3 years. Okay, overall benefit, 2.2 tons. Okay, yep, you can go to the next slide. That's what I was trying to do. So in summary, rather than going and presenting this slide, which Mark Allison has done a lot of times, is actually just present the breakdown. You can see it here when we look at it. There is a range of yield advantages. So where the blue bars are below the 0 axis, there is a yield loss. And where the blue bars on top of the white ones are actually above that, there's a yield advantage. So you can look there, there's more crops that actually have a numerical yield advantage. And it's a very small graph, but I'll summarize that in the next slide. So 27 comparisons between 2017 and 2020. The overall use of a cover crop increased yield of the following potato crop by 2.8 tons. Now, there's an error on there of about a ton per hectare, but a paired t-test has now shown that that was significantly different. So cover crop was advantageous in terms of yield. By comparison, the effect on organic amendments, farmyard manure, compost, straw, paper waste, and so on, increased the yield by slightly less than that, but as yet, it is not significantly different in the number of trials that we've got on organic matter. So cover crops are, whilst not always consistently giving us a yield increase, overall, they are. Okay, next slide, please. So, okay, growing a cover crop incurs some costs, and if you've got to mow crops, if you've got to put a high seed rate in, or fertilize, or even irrigate to establish in some cases, you could be looking at that very top end where it might cost you in excess of £300 a hectare to grow and basically prepare the harvest of that, also prepare the cultivation of that crop. I've picked an average number for the next slide of £210 total cost. Next slide, please. And so when we do a summary, we can say that the cover crop cost on average is about £210 per hectare. If we get a benefit of about 2.8 tons, and people will argue, well, that's not the price, Mark, I've just said it's around about 500 tonnes per hectare based on today's cropping prices, or when I created the slides. So basically there we've got almost twice as much numerical financial advantage by growing that. Now these are based on yields, marketable yields. It takes account of the soil properties. It takes account of some of the aspects of financial advantage, but the improved cultivation speed and extra fuel saving are in the region of 10 to 12% saving. The key when we have these soils in improved condition, and that will be fairly obvious when we come to cultivate, is not to over cultivate them. It's very easy because they're in good structure to over cultivate. Move faster and shallower if we can. Don't create excessively fine seedbeds just because you can, because the cover crop has done that. So where we're focused in this talk is about improving cultivation operations and improving uptake of nutrients so that we gain yield. It's not about pests and pathogens. And one of the things we could alert to is some years we've had sort of detrimental advantages in growing a cover crop versus growing nothing. And certainly some of the work on allelopathy, whereby the cover crop, as you incorporate it, can actually produce chemicals that can cause problems with the succeeding crop. And certainly in potatoes, there are cereal crops, including winter wheat, that would certainly have that effect. So vigorous, leafy, particularly leafy structures can have that sort of allelopathic detrimental effect. Generally, the root structures are not as important in terms of that detrimental effect, but it's still there. So the question I've got right at the end is, I said I wouldn't give you the question, but I'm going to give it to you now, is the hassle factor worth it? So I'm going to leave you, and Alex is going to come in and summarize and go to the Q&A session with the last poll. So next, please. Are cover crops worth the work and trouble? So you get two answers. It's not 100% because that was our dummy test question, but I'll let you dwell on that and we'll return to it at the end of what I can see are several questions coming in. So over to you, Alex.
Thank you for that, Mark. Yeah, some interesting research there, and be interesting to see the poll results at the end of that. So like I say, we'll jump to a Q&A, and then I'll sort of do a bit of conclusion after the Q&A. But just a few questions related on the work you did on spot farms, and I'll just jump in here and say that obviously this year hasn't been the best in terms of getting out and about in terms of an AHD point of view for on-farm field trials. But looking forward to next year, we would like to expand our work into cover crops, as it's something of high importance. So keep an eye out for the spot farm topics for 2021. But why, the first one, Mark, why was cultivations faster on an undefoliated crop? Surely there would not be breakdown of the material causing it to be harder to work with.
It's sort of the logical step forward, and I've certainly been in fields probably 8 years ago where ryegrass was grown as a grazing cover mix. If it was grazed by animals, it didn't prove to be a problem, but where it got to knee height, and then we had to deal with it very close to cultivation, the rate of destoning and trying to move what was effectively sward out of the system, it was zero rate. I mean, it stopped. And so that's the type of question we get, is say, well, it will block up the destoner. The key is chopping. So in other words, whether it's disking or whether we have to mow it, is to prevent that long, almost lignified leafy material binding together with soil and the root ball to give us effectively turfs. That's what I can liken it to. And then that material will have to go out over a destoner or be chopped up by a bed tiller, and will slow the rate of progress. However, what we have observed is if we grow the cover crop and manage it using those chopping techniques, then the benefit of having improved soil structure from a winter of growing that cover crop overcomes the debris that we seem to see in the majority of instances. Now, there will be exceptions still, but it's about managing it right at the point of, when you're coming to do your primary. So again, it's this management hassle that people say it will never work. It does work, and we are surprised how much it does work. And so the key is the desiccation and the management of that particular point, or the chopping if it's still a crop that you're leaving to grow right to the point of primary. Hopefully that will help answer it. It does, and we've measured the effects. So.
No, that's good. Thanks so much. And you mentioned the bed tiller there. There's a question coming. If you need to bed till a field following a cover crop in order to break down fibrous plant material to enable efficient destoning, does this undo much of the benefit?
Yeah, so this is, I'm sure there are people out there that remember my pet subject of probably 2013 to 2016, which is focused on cultivation depth and intensity. And this sort of follows on from that, is that often we bed till soils we don't need to, just to improve the work rate of the destoner. Actually, when you test a lot of fields, that actually isn't happening, because in many cases, the destoner isn't significantly speeded up by that process. And what we do is we overwork soils. So the key that came out of that work 5 years ago was, don't cultivate the bed deeper than you need to remove the clod that you've brought up when soils are wet during the bed forming operation. So that follows on logically when you have debris on the surface that you're trying to bed till, is to basically don't take the whole bed and try and chop up the material with a bed tiller using that way, because all of the soil and the debris you've got will be mixed, effectively blended together, and it won't do the job you expect. So look at managing what's on the surface or close to the surface by keeping the bed tiller shallow, breaking the clods and breaking that fibrous material down. So it's more about depth management than the actual operation itself. Don't go too deep still with that operation. You're trying to macerate green material or lignified material, not overwork the soil deeper in the bed, which should be better structured.
Yeah. So switching it up a bit, Mark, I have found the major challenge of persuading growers to include a catch cover crop in a potato rotation to be consequential increase in slug damage, specifically where Maris piper is grown. The damage is so high that it makes the potential benefits of a cover crop minimal.
Exactly, and this is why right at the beginning of the talk I added the caveat that we have done almost no work on pathogens or pests, and so slug would be a pest on the effect of cover crops. It was one of those things that we were going to add in and we didn't do, but certainly anecdotal evidence is there. I had got a program in 2020 to actually test this effect in terms of measuring slug damage, but unfortunately this year it was deemed that the whole field would have slug pellets applied, and therefore we ended up with virtually no damage in Maris piper on an area with a lot of debris. So, I inspected the crop and gave up because there were virtually no slug holes, not enough to show any treatment effects. So the consequences are there. You've got to have the slugs, and we didn't have slugs, but that could have been a consequence of applying, ferric phosphate. However, we do know that on cover crops which have got green leafy material in, then slug populations are documented to be higher. The question is how are they related to potato damage? We haven't investigated that, but there's almost certainly a link there.
Yeah, I would agree, and I think a while ago AHDB did a project on this, which researched cover cropping in potato rotations, and they found that overall, at all the sites studied, they found there was no evidence that use of cover crops in the winter prior to potatoes affected the presence of slugs associated with a subsequent potato crop. But that doesn't reassure your growers to put a cover crop in. So I think a bit more work might needed to be done on that.
Yeah, I think. Sorry, Alex, if I could just add to that I did present the slide on the overall effects of 27 trials, and obviously what you've got there is you've got a number of negatives and a number of positives. And so what we really wanted to do, and what Anne Stone asked me to do, is take apart some of these crops and say, if they were negative, why were they negative? And one of the things that we could have added to it would have been, well, they were negative because I lost yield because of pest damage. Slugs fed and I lost yield for that. So they were packed out yield. And so I think delving down into the negatives would be a real advantage. It's unlikely that cover crops are going to improve avoidance of pests. That's rare unless we're growing a biofumigant. So it's always going to be negative, particularly for things like slugs. But wireworm would be another issue as well. And so we haven't studied that either.
Okay, moving on. Could a wide CN ratio residue deplete available nutrients?
Yes, and it's this to a certain extent. I wish Mark Allison was here to talk about this, because he talked about it on the CUP open days that we had in the summer, which was when we look at the cover crop that we incorporated. You remember the oat cover crop had somewhere between sort of 50 kilos up to 136 kilos. Is that nitrogen from a fleshy green crop incorporated available in the potato crop immediately, or is it delayed, or is it not available to the crop in the season? We don't really know that. So should we apply nitrogen for our cover crop because it takes out nitrogen? Mark Allison said we don't have that information, and we assume that it's largely neutral in that the cover crop takes it up and then it releases over the course of the season. So if it's delayed and the crop can't take it up before 40, 50, 60 days after emergence, the following potato crop that is, then it will have a detrimental effect on yield if you haven't applied enough nitrogen. But there's a lot of factors that interact there. So we don't know the answer to that one. But certainly if we have a high CN ratio, not those green crops that we had, but something which was more like an oil radish, basically chopped and desiccated in early October, then that CN ratio would be much higher, and probably it would lock up nitrogen. Taking that one step further, we know Andy Whitmore's work at Rothamsted showing incorporation in our project of organic matter, straw being one of the forms of organic matter, was straw tends to lock up nitrogen in the first year of application. So if you extrapolate it, very high carbon nitrogen ratios, so basically straw and lignified materials, would lock up nitrogen and affect the availability of nitrogen in the season after that you're growing the potato crop. So it follows a direction, but it's probably not as significant at the moderate level of CN ratio that we're seeing in these experiments.
And then moving, is there an ideal CN ratio to balance the breakdown with nutrient and carbon uptake?
There probably is. You've seen the sort of numbers that we've got. That the lower the CN ratio, the better the speed of incorporation will be. Whereas if you look at something that is in the 20 and high 20s upwards, it's probably slower in breaking down than something that's in the mid-teens. So, certainly looking at mid-teens as a number and less would be a more rapid breakdown than something in the high 20s and 30s and beyond.
Bit more of a techie question now. Which crops have allelopathic effects and which don't?
I wish I know this. I looked at this morning in preparation because Mark Allison warned me that there might be a question. And if you look at the things, I can read them out. I've got the paper that I printed out. I can read it out. And it's a list of about 35 different crops. And it's a list of probably 20 something weeds, of which many of them American. And I'd have to translate into the UK. So many crops are allelopathic. One that I focused on was wheat, because it's often a preceding crop, and whilst it might be a stubble and therefore relatively low allelopathic residues, if it was allowed to green up as a stubble, which many people do, so it was the leavings from behind the combine, the volunteers effectively, that would be reasonably high on the list of the papers I've read today in preparation for this. But it can be a range of species, and certain weeds can be much higher than normal crop species. However, what I did also read, and this is in my knowledge before I even read the papers, was that certain crop species incorporated along with allelopathic degenerators can actually undo the effects. So, for example, in the States, they use a lot of alfalfa or lucerne, and that actually tends to reduce the effect almost down to zero, or maybe even goes the other way. So what you've got, if you're using mixtures that have got mixtures of legumes, particularly with grasses or with cereals, it might balance out. So there's no particular answer. The story is quite complex, and I thank Martin Cox for sending me the papers this week.
No, thank you for that, Mark. I'm just conscious of time. There are a few more questions. But we'll get back to you those in the coming days. I think I'll draw it to a close now. I just want to say big thank you to you, Mark, for putting in the time and effort to present today. So thank you for that. And just to conclude, I think it's fair to say cover crops can be highly beneficial pre-potatoes and throughout the rotation. However, not all cover crops are the same, and they do have different benefits and limitations. Now, there's much an agronomist can do to ensure the fields are looked after, cared for properly. And I would encourage you all to encourage your growers to try out the cover crops, but make sure you do your due diligence and research. As Mark said in his summary, cover crops have various uses, and do not expect to combine more than 2 of these uses. So make sure you know what your aim is. Is it to increase yield? Is it to improve soil structure? Or is it to control pests? And, if you ever need any advice, I'm sure Mark would be open for a chat, or us here at AHDB can answer your questions or put you in touch with the correct person. So, just the polls come up now. And 73% yes, 27% no. Mark, what are your thoughts on that?
It's where I'd like it to be, because I do fundamentally think that cover crops are worth it. It's just what you've got in terms of management, and that can be a couple of weeks of safety window, and that's where it's crucial to make the right decision. But if you're having to do everything right next to the point when planting operations go ballistic, then it can seem like, well, I got it wrong and it went wrong. It grew too much and I've got all these operations. So, yeah, it's consistent. If it was 50-50, you'd go, well, we still haven't got the story across yet. But the pathogen side of it, worries me in certain circumstances. But from our point of view on the physics of soil, it seems to be beneficial overall for the effort that people put into it. Great.
Yeah, good stuff. Thank you for that, Mark.
Thank you.
So finally, as usual, there's some documents attached below. If you scroll down to the bottom, you can see them. So that's got the arable review, biofumigation guide specifically, and also a specific document on cover crops. Also below is the feedback forms, and I know you've probably been told this 100 times, but if you could please remember to fill those out. I think there's only 3 questions on it or something like that, but it helps us deliver better content to you. And finally, the basis codes and NROSO codes are up, so make a note of that, and don't forget to log them. So I hope you enjoyed this session. Our next session and final session is to do with drip irrigation with slightly saline water at 5 till 6. So make sure you catch that. And with those bits rounded off, that leaves me to say thank you again, and I hope you enjoyed it and you enjoy the rest of your day. Thank you and goodbye.